All right, hello again. This is going to be the presentation on PostgreSQL. I'm Joel Hendrickson, and this is for Cyber 4220. Okay, PostgreSQL, or often it's just called Postgres, is an open source and completely free relational database management system, or RDBMS. What makes PostgreSQL stand out is its strong focus on standards compliance and maintaining data integrity, which ensures that the data is going to be accurate, consistent, and reliable. And it doesn't matter how large or complex the database actually becomes. Another important aspect of Postgres is it's a community-driven development. So instead of being controlled by a single company, it's maintained by a pretty large global community of developers who are continuously improving its performance, security, and the feature sets that are available. The open source model has helped it gain a reputation as being both pretty powerful and rather stable. Postgres is trusted and used by many major organizations around the world for enterprise level systems, large scale web applications, and data analytics. It is known for its flexibility, supporting not just traditional relational database structures, but also object or relational features. So this is going to allow users to create more complex and customized data types. In terms of compatibility, Postgres runs smoothly on all operating systems, to include Linux, Windows, and Mac OS. This makes it very accessible across different environments and infrastructures. And finally, Postgres supports a wide variety of programming languages. It's going to be including most popular like C and C#, C++, Java, Python, and Go, just to name a few. This broad compatibility makes it an excellent choice for developers working on everything from small personal projects to large enterprise level systems. Okay, so one of the kind of key strengths of Postgres is its strict adherence to what's known as ACID compliance. This stands for atomacy, consistency, isolation, and durability. These four principles are going to guarantee that all database transactions are processed reliably, meaning the data remains accurate even in case of power failure or some kind of unexpected interruption. So just kind of an example, atomacy ensures that every transaction is treated as a single unit. It either completes fully or not at all. Consistency ensures that the data always follows the rules and constraints sets within the database. Isolation makes sure that the multiple transactions don't interfere with each other. And durability means that once a transaction is committed, it's permanently saved. This is even if that system ends up crashing. So together, those qualities make Postgres extremely dependable for most critical applications. Another advantage is Postgres' ability to let users define their own data sets, types, operators, and indexing methods. So this level of customization is going to give developers the flexibility to model data in ways that kind of fit their application's needs, something that many traditional database systems might not allow. Postgres also supports multiple data models, which adds to its flexibility. It's not just limited to relational data. It also supports JSON, XML, and key value pair structures. So this means you can store and query structured, semi-structured, and unstructured data, all within the same database environment. Finally, Postgres provides advanced indexing options such as B-tree, hash, and gist, or generalized search trees. These indexing types allow the database to handle different workloads efficiently. For an example, B-tree. B-trees are great for general purpose queries. Hash indexes can speed up the quality searches, and GIST indexes are used for more complex queries like full text searches or geometric data. All right, so some of the architecture. Postgres is built on a client-server architecture. So this means it separates how users connect from how the database actually processes their requests. At the center of this design is the postmaster, also known as the master process. So the postmaster's job is to handle client connections, manage the incoming queries, and coordinate all background processes that keep the database running smoothly. So whenever a new client connects, the postmaster creates a dedicated backend process to handle that. This makes Postgres efficient and scalable, especially when multiple users are connected at once. So another core feature of Postgres is the multi-version concurrency control, or MVCC. MVCC is what allows Postgres to handle multiple reads and writes at the same time without locking users out of the database. It's going to works by creating a snapshot of the data for each transaction. So when one user is editing or inserting data, another user can still read the older stable version of the data. So it's going to ensure consistency while maintaining pretty high performance, and should avoid the bottlenecks that can occur with traditional locking methods. Postgres also uses a page-based storage system managed by its internal storage engine. All the data is stored in a fixed size blocks or pages on the disks. The structure helps the system quickly locate and manage data changes. So to protect the data integrity and provide reliability, Postgres relies on something called write-ahead log, or WAL. The WAL records every change made to the database before those changes are actually written to the main data files. So this is going to ensure that even in the event of a crash or power failure, Postgres can recover pretty quickly and restore the database to its last consistent state without losing any committed transactions. One of Postgres' biggest strengths is its wide range of supported data types, which gives developers the flexibility to store just about any kind of information. Just kind of starting with the basics for the primitive data types, such as integer and big int for whole numbers, boolean for true false, char and varchar for fixed or variable length strings, text for large blocks of text, numeric for precise decimal values, and date for working with calendar-based data. These core data types form the foundation of most databases and make Postgres an excellent choice for traditional applications. Kind of getting past the basics, Postgres also includes the specialized data types that add, a good bit more options here. So with its support with arrays, JSON, JSONB for storing structured or semi-structured data, XML for document-style data, UUIDs for unique identifiers, and range types, which are important for tracking things like numeric intervals or data ranges. These specialized types make Postgres capable of handling diverse and modern data formats used in today's application with the help of an extension called PostGIS. Postgres can even handle spatial and geographic data, which allows you to store and query information like coordinates, maps, and locations. So another key feature is its support for multiple schemas within a single database. This helps organize data more efficiently, allowing for better permission management. So you can separate development, testing, and production data or managed access control for different teams. Postgres also fully supports complex SQL operations like inner left, right, and full joins, giving the user ability to connect and analyze data from multiple tables in flexible ways. When it comes to securing Postgres server, it's important to configure it properly. One of the first steps is adjusting the PG HBA conf file, which controls how users authenticate to the database. So instead of allowing insecure or plain text authentication, PostgreSQL should be configured to use the SCRAM SHA-256 or SSL authentication. This provides a much stronger form of password hashing, helping to protect credentials even if attacker gains access to authentication data. Next, it's going to be essential to limit who can reach the database. So Postgres listens for connections on all network interfaces by default, but that's not particularly safe. You should modify the listen address parameters in the configuration file to include specific IP addresses that need access, in addition to using a firewall to restrict traffic to trusted hosts and block any unauthorized attempts to connect. Another critical security measure is to encrypt client's server communications using SSL or TLS with valid certificates. And then finally, making sure that you're keeping everything up to date with patches, security updates, and running automated backups. All right, just to summarize, Postgres is an open source, highly powerful relational database management system that's capable of handling a wide variety of workloads from small scale applications to enterprise level deployment. It's free and it offers extensibility, performance, and reliability that rival many commercial or paid database systems. And it's very versatile. It runs seamlessly across Linux, Windows, Mac OS, and it supports a wide range of programming languages. It's fully ACID compliant, and it allows users to define data how they need it.